Statistical hypothesis is an assumption about a population parameter, like population mean, etc. Now to check if the assumption is true or not, we conduct hypothesis testing. So how do we do it? We first define null hypothesis and alternate hypothesis. Null hypothesis is true unless it is proven otherwise, while alternate hypothesis is what we wish to conclude. Let's see a few examples. Suppose a company is selling wine and it claims that each bottle of wine contains at least 300 ml of wine. So the claim that bottle has on an average 300 ml of wine is true unless proven false. So this will be our null hypothesis. Mu is greater than or equal to 300 ml. Now what we wish to conclude to see if our null hypothesis is true or not, the average quantity of wine is less than 300 ml. Mu is less than 300 ml will be our alternate hypothesis. Let's see one more example. Here on an average, the monthly salary of a fresh graduate engineer trainee is considered as 30k INR, which is Indian rupees. Now we want to see if this claim is true or not. So we take a sample of engineers and see if the average salary is 30,000, which is our hypothesis, or it is not equal to 30,000. So here if salary is less or more than 30,000, our null hypothesis will be proved false. This is called two-tailed test because we are testing the equality here. The example of wine bottle is called one-tailed test. In one-tailed test, we test null hypothesis if it is greater than or lower than something. We'll see these tests in detail. But before that, first understand what is statistical significance. Now, statistical significance is a measure to tell if our research findings are meaningful or not. So how do we decide this? We set up a hypothesis and then we choose an alpha level. Alpha level is the error rate with which we are willing to work. It is also called significance level. Usually it is 5%, but it depends on the problem at hand and can be decided accordingly. Now once we have decided our alpha level, then we calculate the test statistic such as t statistic or z statistic. After that, we calculate p-value using the t statistic and compare it with alpha level. Now what is p-value? P-value is the percentage chance that our results happen randomly. So obviously a smaller p-value is desirable for us. That is a smaller chance of our results being random. Or you can say in simple terms, p-value is the probability that helps us decide whether the null hypothesis is to be rejected or not. Now if p-value is less than alpha, so we reject the null hypothesis. Otherwise we fail to reject it. So that is how p-value helps us in making the conclusion about our hypothesis. Now if you see the graph, here the shaded area under the curve is the p-value. First curve is showing p-value for a two-tailed test, and second and third curves are showing one-tailed test with left and right tails respectively. Now we have another approach to test our null hypothesis, that is called as critical region approach. In this approach, we find the critical value using alpha and then compare it with the t statistic. Now I'm not going into more details of it. It's a pretty simple method and one can Google it as needed. But p-value approach that we are going to use is a widely used method, so we'll stick with it only.